Okay. Hello, everybody. So I'm Fengbo. I'm founder and CEO of Fovus. We are, sorry, I might have clicked. Okay, there you go. So we are a partner of AWS for high performance computing. So it's my great pleasure to share some insights on how Fovus solves some of the major cloud infrastructure challenges in general in biotech and life science, digital R&D. So there's a very strong trend that we're seeing that cloud is becoming increasingly popular place to tap into the supercomputing power needed in order to support the computational AI-driven, right, drug discovery, bioinformatic pipeline, those kind of bioinformatics or cheminformatics workload. Um, because of all these great benefits, right, low cost of ownership, high elasticity, timely infrastructure upgrade, high data accessibility, availability, these are all great, but also it comes with these great benefits, also come with great challenges. Um, First of all, it's a pretty complex environment, right? So somebody, usually that's the IT team in a large company, has to set up and manage the cloud environment for doing computing at that scale, which is very time consuming and distracting. And in some cases, the scientists, the computational scientists are unfortunately forced to manage some of these efforts, especially in a smaller company. But they really wanted to spend their valuable time on the actual science and innovation, right? And also, I think this is an even bigger challenge. In the case of AWS, for example, the offering is so diverse and heterogeneous, right? Which is great from the infrastructure perspective, but it's a big pain from the user perspective because um, really wanted to know what is the optimal configuration that you should use to run each type of your workload, right? So that you can get a minimum time and cost. But unfortunately, there's no transparency. So most of the time, what we see is that people do some limited exploration, but in many cases, they cannot even afford to do that. So they fly blind, use naive strategy, fixed strategy, do manual tuning, right? For apply the same strategy to many different workload. As a result, their strategy is highly suboptimal, and they end up with very wasteful about the way to use cloud resources. So they complains about a large cost. They feel it's so expensive to do things at scale. But unfortunately, that's just a misconception because they're not using these cloud resources in a very optimal, efficient way, unfortunately. And they don't know how to improve. Another big problem that we hear all the time, it's GPU and spot instance scarcity. Sorry. Um, and because you are using these cloud resources in the in most cases, you are in the isolated single cloud region, or you're competing these resources with people that you don't know, right? And especially for these high demanding resources like GPU, when you want to scale up, it doesn't really happen, right? A lot of time you're just waiting for your job is just being idle and waiting for available resources. So as a result, you get unpredictable workload runtime. Most of the time, that's just waiting for resources. There's no predictability. But on top of that, what's also difficult is that AWS keep changing, right? Every few months, you see next generation hardware comes out. AWS rolled out a new infrastructure. In theory, this is the beauty about cloud HPC because you have state-of-art hardware. But in practice, this is a big pain. How do you keep track of these things, right? Are you upgrading even your infrastructure as a code timely? Do you understand if these new hardware works better for your workload or no? These are all uncertainty. So we're seeing in practice there's a very big gap and delay in the practical adoption of these new hardware. So if you're facing similar challenges, you must be looking for a solution. That's exactly the reason why we built Fovus. So Fovus is the world first AI-powered serverless HPC platform. The idea is very simple. Let's forget about the human-driven, fixed setup, manual tuning approach that we have been using. Let's use AI. Let's use data-driven approach to handle that. Take human out of the loop, right? Let AI, let the data-driven approach handle the entire strategy optimization. Understand what you're running, figure out what's the right configuration strategy for each workload in real time, and then apply that and drive the automation, right? To automate the entire logistic so that you can really just focus on innovation, right? But at the same time, now you can finally enjoy the benefits, the efficiency, and the optimality benefits, which is assured by data-driven approach, right? Which is impossible to do with human-driven approach. So let me show you how this really work from the user perspective. So we provide a super intuitive interface because now we do optimization, we do automation about the logistic, about the HPC strategy. Now the only thing that you have to do as a user or as an IT team is manage the interface. But the only thing left for you is to deploy the workload. That's all you have to do. So you can deploy the workload with our command line interface or web interface with a single command or a few clicks, whether that's a large batch workload, any type of simulation, AI training, inference, or if that's a bioinformatic pipeline, right? For example, Nightflow pipeline, you can just launch them just with a single command, as simple as that. So you don't have to manage your AWS batch environment anymore. You don't have to define your compute environment. You don't have to manage your P cluster. You don't have to do that anymore. Okay, so you just focus on deploying. We do all the heavy lifting behind the scene, and we do all the optimization in a dynamic fashion. So it becomes super easy for you to scale, deploy, migrate, and use. And in order to make the magic happen, there's multiple levels of optimization we do behind the scenes. So first of all, we have the world's most sophisticated benchmarking engine. So we take your production workload, we benchmark them against every applicable HPC strategy on AWS to quantitatively understand how different compute, memory, storage, networking, parallel computing setting, all these different configurations, how they impact the time and cost for running each of your production workload, each of your process. We collect the database, we create a benchmarking profile for each of those processes. So our system now have the visibility. And the best part is that this is a free automated process. You don't even pay for the benchmarking. We cover the cost, you enjoy the benefits. So you feel free to benchmark as many production workloads as you have. We take care of that. So once we have the data, then when you deploy your production workload, that's where the magic starts to happen. So our system would actually pull the data, right? We know what you're running, we pull the data, we use the data to make prediction, right? In terms of time and cost across different strategy. And then on top of that, we can determine what is the optimal configuration to minimize your runtime and cost, right? In a real-time fashion. And this real-time optimization is done subject to the availability and pricing dynamics in the cloud, as well as user objective. You can even define how much importance you want to place on time versus cost minimization. This is always the trade-off for each of the job or each of the pipeline that you launch, so that you can easily get a different strategy for your timing critical versus cost sensitive workload, right? Depending on what you're running. So, but it's very simple control dial that you can just tune, and then you get the optimal strategy automatically. And then to address the GPU and spot availability and scarcity challenge, we federate availability resources across AWS on two dimensions. In the first dimension, we federate availability across multiple strategies because now we have your benchmarking data. When we know what is the first optimal, second optimal, third optimal strategy, right, for running a particular workload, we simply distribute your workload, start with the first optimal, right, top from the list. Once we exhaust all the availability, then we can automatically go and build an infrastructure for a second optimal strategy, further distribute, so on and so forth, right? We go down the list depending on what really is the most efficient way to run your workload automatically. You don't have to compile this list. You don't have to define what is it in this, how we distribute it. It's figured out by AI, figured out by data-driven approach, right? For each workload, imagine this list is going to be very different, right? Depending on what you're running. And also we federate availability across multiple AWS regions, right? So not only, so for each strategy, we actually search availability. We have our own way of monitor availability across multiple AWS regions. We distribute our workload depending on where it really has the best availability for the best resources, right? We distribute it across the region, and once we exhausted all that, and then we further distribute across strategy in 2 dimensions. So this way we can very effectively scale up compute fleet for GPU, for spot instances to a pretty large scale very quickly. And you don't have to worry about the control, right? You just switch a button to say, okay, help me distribute the workload. And also we automatically leverage spot instances. And again, this is purely data-driven, very intelligent. We know your benchmarking data. We monitor the availability and pricing of spot instances, right? We use all these information, also the interruption probability data. We use all these information to, again, build a statistical model and then make prediction, right? So we know, okay, if for this workload, should we use spot strategy? If yes, what is the first, second, third optimal spot strategy that we should use, and then we distribute that across them, right? You may ask, what if my workload doesn't support checkpointing, right? And then when interruption happens, then I have to restart from scratch. Well, the best part is that we also provide memory checkpointing. So we actually checkpoints application execution status at a container level. So even if your workload is long running, doesn't have checkpointing support, native support, that's okay. As long as it's containerized, we take a snapshot periodically, as well as upon spot interruption incrementally. And so once in spot interruption happens, we just need to rerun the strategy optimization, find another optimal spot instance somewhere else, resume the computation from the last safe checkpoint, so you don't lose much computation. So this way, you can also very effectively use spot instances, even for your long-running heavy workload that used to be impossible to use spot instances. And on top of all this, we also automatically upgrade our HPC strategy, because now we have benchmarking, we have optimization in place in real time, right? Automated. So once AWS has rolled out the next generation GPU, CPU architecture, things like that, we can detect them. We automatically run additional benchmarking, understand, are they working better, right? Are they cheaper and faster to run for your particular workload? And they are. We automatically switch the strategy, start leveraging these new infrastructure. And this happens automatically behind the scenes. So you don't have to change your code flow, about upgrading infrastructure code anymore. Now system understands what matters, what fits, and then automatically the strategy as AWS keep improving, keep upgrading their infrastructure, so that you can always timely leverage the state-of-art hardware to drive the performance. What's the real-world impact? I have 3 very brief case studies. So this is a customer running large-scale GROMACS simulation. They actually wanted to run it across hundreds of GPUs, but again, within a single region, they face challenge provision even more than 10 GPU. Beyond that is pure luck, right? Depending on availability, depending on the combination of resources, what GPU that you're using. Scale beyond that has become really hard within a single region. And also, they're not sure even that's the right GPU size configuration to even use in the first place, right? So they end up with launching a very large-scale compound screening that would actually take more than 4 weeks to complete. A lot of time are just waiting for available GPUs, and it will cost them more than $5,000. Now with Fovus, we benchmark it, understand the right configuration, right GPU choices, right size it, right parallel computing setting, and then we distribute them across multiple region, multiple strategy. And then the best part is that all of those are actually spot GPU. We actually help them launch, I think, almost 500 spot GPUs within 20 minutes, distribute them, get everything running in parallel. So as a result, this whole workload is done just in 6 hours, but at the same time, cutting down their cost by 85%. Very similar story. This is a 500 million lagging high throughput virtual training. The customer used to do this in multiple cycles of traditional docking, AI training, fine tuning, and then do inference, and then fine tune the AI model until it's accurate enough, and then do the inference on the entire library, pick the top 10, and then do the traditional docking to validate the result and things like that. But this very complex workflow, right, in multiple cycles. And this is super heavy CPU usage, facing exactly the same challenge: scalability challenge, strategy challenge, complexity challenge, right? So previously they have to spend more than $20,000 to get this entire thing done, screening done in 24 days. This is pure computational time. This is not even doesn't involve the time the human has to look into the result. But again, a lot of these time actually waiting for resources, and also the inefficiency about using the resources. Now with Fovus, right, we do all the optimization. We are able to launch tens of thousands of CPU cores, right, very easily with the optimal strategy, get everything running in parallel. So at a workload level, we're reducing their runtime by 10 to 100 times, depending on the scale that they need to run the workload. But at the same time, cutting down their cloud expenses by 5 to 8 times. And this is also a very interesting case study for bioinformatic pipelines. This is the NF core RNA sequencing, because for bioinformatic pipelines, they're even more complex. They're even more sensitive to optimization, right? Because each pipeline might have 50 to 100 different processes doing very different things. Ideally, they should require different configuration in order to be time and cost efficient. But unfortunately, it's too complex to manage. most of the time we're seeing customers do very limited exploration. So they either apply a fixed strategy, right, across the entire pipeline. At best, they maybe tune the vCPU and the memory a little bit, right, into maybe low, medium, high profile. That's the best they do. Or apply a fixed type of optimization. For example, Fusion 2.0, right? Let's use a parallel file system to improve the I/O performance. But then the question becomes, do you really need that, right? For the entire process pipeline, regardless of what you're running, you're applying the same I/O parallel file system, which is very expensive to use to all the process. The question is, do those processes are really that I/O bounded? Do they really need that? So these are some of the cost numbers for running the entire pipeline with the 8 samples. Yeah, as you can see, depending on these approaches are either using fixed setup, human-driven setup, or at the best, they use a fixed type of optimization, either memory or storage. But it doesn't matter what you're running, they apply the same type of technology across all these pipelines. So as a result, you're looking at a cost ranges from, depending on whether you use on-demand or you're able to use spot instances, you're looking at a cost range from $20 to almost $100, depending on what optimization you apply, right? But are they optimal? No, because these are not even data-driven, right? These approach is not about understanding what you're running and then apply the right configuration. It's about always apply the same strategy, same configuration, no matter what you're running. So if you happen to have some process that fits that, you get benefits. Otherwise, you don't, right? Now with Fovus, our benchmarking engine automatically understands the characteristic for each of the major processes within the pipeline, and in real time, use these data to build a dedicated optimal cloud HPC environment for each of these processes. We dynamically manage this environment with batch or P-cluster, and then we dynamically delete, create compute environment depending on what's optimal and manage that automatically in real time, right? So making sure every single process, depending on how compute bounded they are, how I/O bounded they are, how memory bounded they are, how network bounded they are, right? Whether they have a good parallel efficiency or no, make sure that we build a very dedicated environment for each of these processes, and that's where you can get to. Optimally, you just need to spend $5 to run this whole thing. Yeah, hopefully, given limited time, I think just jump to. Oh, okay. So I'll just wrap up the talk. Hopefully, this gives you overview about how important data-driven optimization is on the infrastructure level. If you're running a large-scale compute in your company, we're at booth 617, and we're out for free trial, and we can get your workload benchmark for free. So feel free to come to our booth. We'll make sure we get your question answered by our expert. Thank you.